Hello everyone, welcome to module 5 and today we will start this with lecture number 13 and here we will have the introduction to floods. So this is the part 1 of this lecture 13. As usual we will have the second part after this lecture, right. So in this lecture we will learn about the flood and what are the different causes which triggers the flood and what are the different positive and negative aspects of flood, and then we will also learn what are the different types of flood, right. So let us start with the basics of flood. So here you can see there are different images, right, which is showing the flood and the impact of flood that you can understand. So a flood is essentially an overflow of water onto land that is normally dry. So as we all know that flood is a difficult situation and many of us might have the experience of flood. So flood is a deadly disaster, natural disaster, but it is also very important for agriculture and to maintain the life of plants and the animals, right. So this is a disaster which is having both positive and negative sides. So let us understand this flood in detail. So a flood is the inundation of a normally dry region caused by an increase in water in a river or stream, right. A flood occurs when a system crosses the geomorphic threshold. So when we see a cross section of a river, right, normally we have the water up to this level, right. So what is the geomorphic threshold for this section? This is the geomorphic threshold. So once the water reaches to this level and when we have extra water, it will start spilling outside and which is crossing the geomorphic threshold, right. It is considered to be a temporary condition because we have this situation because of some heavy rainfall or maybe breaching of a dam or maybe there is a blockage of the pathways, right. So an overflow of inland or tidal water, this could be the case in flood. Then we have rapid runoff of surface water. So in flood what happens? We have excess amount of water which cannot be controlled or maintained by our fluvial system and that is getting overflowed, right. So here it is rapid runoff of surface water. This is the scenario when we have the flood. When we talk about the factors, we have two different factors. First one is intrinsic and then extrinsic. When we talk about intrinsic, we have heavy precipitation and then aggradation of river beds. And for extrinsic factor, we have breaching of dam. This is one of the example. Now, when we talk about heavy precipitation or aggradation of river bed or breaching of dam, all are resulting in some excess water, right, excess water. And these excess water is not getting accommodated by our fluvial system and because of that it crosses the geomorphic threshold of that particular river, right, or maybe a lake. So then we have overflow and this is the situation when we have flood in our river system. So I have used some of the images to help you to understand the impact of flood. So here this particular image is from Assam, you can see, right, and how people are surviving. Then this image, this one, it is from Haflong, right. So this is from 2022 and you can see all the railway lines are blocked. This particular image is from Vijayawada city, this is from 2024. So that might have helped you to understand the impact of flood if you have not experienced one. Then when we talk about the important factors which plays critical role in flood, so here the first one is the land use land cover, then we have catchment size, then we have drainage, then rainfall, then antecedent condition, this is antecedent moisture condition, then catchment shape, then we have vegetation, then geology of that area, what is the topography of that area, and then meteorological conditions. So, here all these plays critical role in flood. So, one by one we will try to understand all these parameter or the factors which are playing critical role. So, when we talk about the vegetation, infiltration and runoff, this vegetation plays a critical role. Vegetation causes an increase in soil porosity and infiltration rate, thereby reducing the surface runoff and causing delayed peak discharge, right. Then interception, the vegetation intercepts precipitation, which slows the rate at which water reaches the ground and reduces the runoff. So, ultimately if this is the catchment, right, and here you have these tributaries or the streams. So, where we measure the discharge? Here, right, and then we try to make this curve. Now, here when we try to see the response of a precipitation and at what rate the discharge has taken place here, the vegetation will have the major role because it will delay the process. So, what happens when there is a precipitation? It slows the rate at which water reaches the ground and reduces the runoff. Then it also plays a critical role. It also plays a critical role in evapotranspiration. It affects the evapotranspiration that causes a reduction of water availability in the catchment area and result in lower flood risk, right. Now, let us talk about the land use and land cover. So, land use and land cover are two parameters, but we always consider them together because land use is how we are utilizing them, right, and land cover is what is the natural land cover, how it has been before we utilize them, right. So, it is very difficult to segregate these two. So, when we talk about this land use land cover, urban area and cultivated lands, these two different forms will help you to understand what is the role of water and how it is taking place and how it is governing this flood. In urban area, what happened? It increases the runoff due to the paved roads and drainage systems. This leads to short lag time and high peak flow. This I will try to explain in the next few lectures. So, when we will have the peak flow and the precipitation together, we will plot them and we will try to see what is lag time and how we derive the high peak flow, right. So, then comes the cultivated land. Deforested land and the change in land use compact the soil, reducing the permeability and resulting in overland flow. Due to this land use land cover conversion, what happens? The permeability changes and which results in overland flow. The installation of field drains further accelerates the runoff into the nearby stream, thereby affecting flood dynamics. So, the dynamics will be very different when we have the installation of field drains, right. So, here you can see some of the example how it is flowing and then how it can cross the geomorphic limit and how it is causing the flooding into this area, right. When we talk about the soil, we all know that flood has direct relationship with the soil type. So, the rate of infiltration is affected by the soil texture. Soil thickness affects the absorption of water in the soil. So, let us say here we have a column of soil, right. So, if I put this sandy soil here, what will happen? Permeability is high. That means it will have high permeability. So, the water which is coming from this rainfall, that will go inside this, right, and then the overflow or the surface runoff will be less. When we have clay soil, if we remove this sandy soil with the clay soil, right, what will happen? Permeability is low. So, here this permeability is less than your sandy soil. So, in that case, whatever water we are getting from this precipitation, we will have overflow, right, and this overflow will cause the flooding in the downstream area. Then comes the geology of that region. The impact of geology on drainage basin and its corresponding response is given here. So, when we are having the permeability, then precipitation, the response to precipitation is slow, right. If it is impermeable, then it will be very fast. So, let us try to understand. If we have a column of soil, right, if permeability is high, right, that means if you have heavy precipitation here, it will have slow response to the precipitation. That means water will be accommodated into this. So, you will have less or slow response. If it is impermeable, what will happen? Nothing will go here and everything will be in the form of surface runoff, right. So, that is the meaning of this table. When we talk about the drainage size and shape, so let us talk about the larger basin. So, let us say I have a larger basin like this, right, and here we have a outlet point where we are measuring the discharge, right. Now, if suppose if we have precipitation in this region, then this water will take longer time to reach at this particular point, so, and but this discharge will be the cumulative of all water falling in this particular area, right. So, this is the meaning of larger basin. When we talk about the elongated basin, so the same condition we will have the larger basin, but in the elongated form. So, let us say like this, and here we are measuring the discharge. So, what happens when we have the heavy precipitation in this region? This stream will quickly deliver this water to the main stream, right, and then it will quickly reaches to this particular point. So, respond quickly but with gentle peak. Why? Because this is long time is taken by the water to travel, right. So, the peak will be gentle. In the other one, it will be like this, right. So, that is the difference. When we talk about the drainage density, high drainage density reduces the flow path and rapid runoff. So, the density, what is the rate or what is the rate of density here? So, if you have higher density, you will have rapid runoff. We have another parameter, drainage basin topography. Travel time increases over the steep slope, whether it is having the steep slope or whether it is having the gentle slope. That will also help the water to reaches to this particular discharge point. In the upland area, the steep slopes are related to thin soil, leading to rapid response, because below this thin soil we have the rocks. It may be permeable or impermeable, but at least they will be less permeable than the soil, right. So, because of that you have rapid response. Rainfall patterns are influenced by altitude, and aspects. So, this is the altitude, right. You can calculate the slope, and then we have the aspect. What is the aspect of that? So, once you have the digital elevation model, you can calculate the altitude, you can have the slope, you can have the aspect, what is the direction of the slope, right. Then comes the channel and floodplain resistance. The channel shape and the roughness of the river bed and the bank affect the flow velocity of the river channel. So, you can try to visualize this, what are the different shapes, channel shapes, what is the roughness of the river bed and the bank, right. So, that all controls the flow velocity. Overflow banks are slowed by the roughness of the floodplain surfaces. So, that I will try to show you some of the example in form of images, so that you will be able to understand this channel and floodplain resistance. Then floodplain storage. When the river exceeds its capacity, the surplus water flows into the surrounding floodplain areas, right. This stores the flood water temporarily and reduces the downward flow. So, let us say you have a river system, and some of the regions you have the floodplains, right. So, these floodplains are the adjacent areas which can accommodate the extra water temporarily, and this reduces the surface runoff in the main stream. So, this will also delay the flooding, right. Then conveyance losses. In the dry region, the channel may lose water due to high rate of evaporation, then leakage by exfiltration through the boundary of the channel, right. So, if there is some other areas which is getting feeded by this water. Then antecedent condition, it is basically antecedent moisture condition. It refers to the state of drainage basin before the rainfall begins. In areas with saturated soil due to previous rain, even a small amount of water shall cause huge runoff. Let us take the example of a dry soil. So, let you collect some saturated soil and dry it, and then try to pour 1 glass of water here. What will happen? Immediately this will start flowing. This will not be absorbed, right. So, because it is in the dry condition, it is not even behaving like a sandy soil or clay soil, but once it reaches to its normal moisture condition, it will start the percolation, right. Then this overflow or the surface runoff will be less. But if suppose if this particular soil is already saturated and you are pouring 1 glass of water, what will happen? The entire 1 glass water will be coming to your downstream as your discharge, right. In snow laden areas, subsequent precipitation can lead to snow melting and eventually lead to flooding downstream. So, this is very obvious. Then you have rainfall intensity. Intense rainfall exceeds the soil's infiltration capacity and leads to rapid runoff, because what will happen? This soil will get saturated and then you will have the runoff, and this runoff will be directly proportional to your rainfall. Rainfall duration. Longer rainfall duration activate the runoff from greater distances, thereby extending the channel network. So, what happens? We have intensity and duration. So, if you see the graph, right, let us say this is for the precipitation. So, what is the peak precipitation here that you can measure? How much mm it is, right, or centimeter. So, what is the intensity and what is the duration? If it is for longer duration, what will happen? This will be feeding more water to the fluvial system, and then we will have more problem related to flood. So, when we talk about the drainage basin, it is an area which is drained by the stream and its tributaries, right, also known as a catchment area or a watershed. It is crucial to understand the characteristic of drainage basin for flood prediction, because unless until you do not know your area, how you will be able to predict or how you will be able to model, right. So, this is one example of drainage basin. The features such as shape, size, slope of the basin etc. influences the flow of water, thereby helping in determining the associated flood risk in a region. So, here you can see this is the shape . So, this is the shape of this drainage basin and these are the main channel, right. This is the tributaries, right. And now, we also know that what is the slope and the basin size, that is clear from this, and the shape, right. So, all these are very important parameter when we consider the drainage basin or the catchment. So, there are different drainage patterns. So, here is the example of dendritic pattern, then we have this, then we have another form, then we have this parallel pattern, then rectangular pattern, then centripetal pattern, then highly violent pattern. So, you can see how it is getting violent because it is having too many main stream and the tributaries, right. So, when we talk about the drainage texture, the drainage texture is the relative spacing of drainage line, right, influenced by various factors such as climate, lithology, then geology of that particular area and then relief also. It can be classified into fine, medium and coarse, with drainage density being an important indicator. So, here the drainage density will be used to have different drainage texture, right. Drainage density can be defined as the total stream length per unit area of drainage area, right. So, using this you can calculate. So, here when we have drainage density approximately 0.93 kilometer per kilometer square, right, we have this steep impervious area. Highly permeable basin, it is 0, humid region it is 2 to 0.6. This is from this particular paper, right. Then we have the texture and corresponding drainage density. So, here it is from Smith and Staller. So, here when we have the fine texture, the drainage density is in this range. When we have medium texture, it is in the order of 5 to 15. When we have coarse, it is less than 5, right. So, this is how we define the drainage texture. Then we will talk about the stream order, because there are many ways you can order the stream channel, right. So, here one is given by Horton, then Staller, then we have different styles, right. So, the stream order is a method used to classify the hierarchy of a river's tributaries, right. You can see here how it is given the number. The low order streams are small tributaries and have narrow channels. These steep gradient streams may cause intense flooding due to limited storage capacity. The higher order streams are formed when many tributaries combine. They have slower moving floods compared to the first case. So, I will try to explain this Staller one, right. So, here let us say this is one catchment area, right, and here there are two tributaries which are meeting and they are making one bigger tributary, right. So, here we will name it 1, 1 first order, then when 2 first order meets, this will become second order, right. Then from here also 2 first order they are meeting and they are making this second order. Then these 2 second order, when they meet, they make this third order stream, right. And then similarly, if you have another 1, 1, then you have 2, and then when these 2 are meeting, 2 and 3, this will remain the higher order. So, 2, 3 means third order only, and if there is another one which is coming third order and third order, this will make fourth order, right. So, this is same thing is explained here. This is how we order the stream. So, higher the order, you have more water because this is coming from all these streams, right. So, let us talk about the hydrograph, which is one of the very important characteristic. So, a hydrograph can be defined as a response of a given catchment to rainfall. This is a typical hydrograph. Here you can see the discharge is given and x axis is the time. Now, let us say this is the discharge one, this is discharge, right, and here you have different elements. So, when we talk about this hydrograph, we have different elements. So, here you have rising limb. So, A to B, that is your rising limb, then B to C is the crest, right. Then you have C to D, that is the falling limb, and then DN is the base flow recession, right. This is the line which is connecting these two, A and D. So, depending upon the shape of this hydrograph, you will be able to say or comment what is the status of your area, of your catchment with respect to a given rainfall, right. So, here when we talk about this factors which are affecting the flood hydrograph, so the basin characteristic, storm characteristic, initial loss and evapotranspiration, this all will lead to this graph. So, they have very important role here. Then you have infiltration characteristic and then you have channel characteristic. So, we will continue this discussion in the next part. Thank you very much for listening. So, we will continue this lecture 13. Thank you.